Okay, this video will be over graphing absolute value functions, and we have the standard form of an absolute value function. Sometimes you'll have absolute value functions that are not set equal to y, and you'll have to do some work to get it into this form, but we're going to focus on this type today. The key is finding your vertex first, and to find the x-coordinate of your vertex you have to take what's inside of the absolute value symbols and set it equal to 0 and solve it. And your y value for your vertex is always going to be k, the constant out front. Okay, and then you can also keep this in mind, the direction. If a, this leading number out here, is greater than 0, it's going, or positive, it's going to open up like a V. And if a is less than 0, which is negative, if a is negative, it's going to be a downwards V. So if you keep those in mind every time you do these, it could really help you. Another thing too that I don't have listed here is that your slope, you can look in front of x, and a times whatever's in front of x will be your slope. So here we go, let's try this one. So when I look at this one, if I rewrote this as -3 2x plus 0 plus 2, since all I did was add plus 0 there to make it look like this. So obviously in this case our h is 0. But you can also just think about this too. What makes inside of that absolute value 0? So you basically do 2x equals 0, and obviously x has to equal 0. So my x coordinate of my vertex is 0, and my y coordinate is not k, it's 2. Okay, so 0, 2 is my vertex, which we could call our inflection point also. So this is where it's going to change direction. You know, it's a very important point. Okay, now since a is negative, I'm expecting this thing to open downward, and if I'm good at this, I can do -3 times 2 and know that my slope's going to be +6 and -6 from that point. So if I go down 6, 2, 4, 6, and over 1, it's going to be there. If I go down 6 and left, that's going to make a positive slope. Now, if you're using the slope method, what I've encouraged people to do is make sure that those points make sense. So plug in 1, because according to this, when I plug in 1, I should get -4. So let's see if that happens. I have -3, plug in 1, plus 2. So absolute value of 2 is 2, -3 times 2 is -6, plus 2 is -4. So the point 1, -4 ended up being on my graph, and I was right. So if the slope here is -6 to 1, this is going to be +6 to 1. So it's just the opposite. Our domain, it doesn't matter what I plug in for x, it'll work. So we use that symbol for all reals. And then our range, think about this. I could plug in x's all day and I would never get a y that's greater than 2. Okay? It also shows up here in the vertex. Since this vertex is a maximum point, alright, 2 is the high as it's going to go. Alright, so I want to make sure I write this with the smaller number to the left, so from -infinity up to 2, and include 2. Okay, this one, vertex. I'm going to find the vertex by setting that equal to 0, and when it's like that and a, the leading coefficient is 1, it's pretty easy. That's obviously 1, and then -2. So 1, -2 is right there. I'm expecting the direction of this to, in general, be like that. Okay, it's going to be opening upward. My domain is all reals. We'll talk about the range in a second. And again, I can look for my slope out in front of x. Looks like my slope is going to be +1 and -1. Now, I could also go to a XY chart very quickly. I know that this is my vertex, so it'd be smart to plug in a couple on the right, to the right of it, and a couple to the left of it. So a lot of times I've been putting a line across just to kind of show, hey, this is to the left, and these three are going to be to the right of the vertex, and here we go. So I'm not going to show all my work here. I just, you kind of have to walk yourself through it. You have to do this by hand. Most calculators won't do absolute value, but 0 minus 1 is -1, but the absolute value of -1 is 1. So 1 minus 2 is -1. Plug in -1, I get -2 here, but the absolute value of -2 is 2, and 2 minus 2 is 0. So now I see this pattern is going up 1 and over 1, and really an absolute value, at least in this case, this is a linear type of linear function. So even though I'm not plugging these points in, I can expect that to keep going in that direction. Now, this is my inflection point, so I'm expecting this thing to go the other way with the same slope, well, the opposite slope, really. This is -1 to 1. I expect this to go +1 to 1. Now, again, I would plug this in and see what happens. 2 minus 1 is 1. 1 minus 2 is -1. So I checked that point right there, and it checked out. When I plugged in 2, I got -1. So I'm thinking the correct direction here. So go ahead and connect your dots. This thing keeps going forever and ever. Put the arrows there. There we go. Now this is a minimum point this time. It's a minimum point. It says low. The lowest y value we're going to get. Oops, the lowest y value we're going to get is -2. So square bracket, -2 to infinity makes sense for our range. Remember, range is a y thing, domain is an x thing. This one I'm going to go kind of quick. It's key to see that the k is 0 here. So our vertex is 4, 0. 4, 0 is right here. Okay, so that's my point of inflection. And then I also know that this is positive, so I'm expecting this to look like that. Not be flipped over, it's going to be a V. My slope is 1, but I could also plug in values very quickly in an XY chart, and get my points. So try 5 and 6, that's on the right side of it. 5 minus 4, that's not hard, that's 1. Okay, 6 minus 4, that's 2. So 5, 1, 6, 2, that's on that side of it. So some teachers will suggest that you draw a line of symmetry with a dashed mark. It's not a bad idea, just to kind of know that, hey, I have a right side and I have a left side. You can try 3, 2, and 1, and when you plug in 3, 3 minus 4 is -1, but the absolute value makes it positive. 2 minus 4 is -2, but absolute value makes it positive. So see how I have a symmetrical graph there, and I could just continue that pattern and get all the points on the graph, not just a few. And there you go. So domain, all reals, range. Now be careful on this one. I had some people miss this one today. It goes from 0 to infinity. Why do I say 0? Because the x-axis is the line y equals 0. Think about it. So again, you can look here for, that's your lowest point. You could plug in all kinds of x's all day and you would never get anything less than 0. Okay. And then again, our slope is 1 to 1. You can get that from the equation, or you can get it off the graph. So -1 and +1 are your slopes. Now, another thing, if you're watching this from a different class, there's a lot better way to write this, to write for your slope, because since it's an interval and it changes, you could say that slope and it's -1 where x is less than 4, and it's +1 where x is greater than 4. So that's just a little bit more technical way of writing and showing the user, hey, when it's less than 4, it's negative slope, and when it's greater than 4, it's positive slope of 1 to 1. Okay, number 11, I already have it completed. I just wanted you to look at that one. I'm expecting it to flip because A is negative. 2 makes this 0 inside of there, and the -2, so be careful with that. There's a lot of negatives flying around in that one. All right, number 17. This really tests whether you understand that to find the x-coordinate of your vertex, you need to take what's inside of the absolute value and set it equal to 0. It's not real clean. And then my y value is still going to be 2. So I got to think about that before a lot of people were just looking at that and saying, hey, the x-coordinate is 2. That's not right. So you have to think, so 3x minus, or negative 3x minus 2 equals 0. Solving that, obviously add 2, and then divide by -3. So x equals -3/2, or -2/3. Okay, so -2/3, 2. Now, -2/3 is not the easiest thing to graph, but that's just 2/3 of the way to -1, and then up 2. Okay, now my slope, if I look at this, it looks like it's 3. So I could count, down 3 and over 1, but counting over 1 from 2/3 is a little messy. So what I would do is I would just go straight to plugging in, x right now I know when x is -2/3, I get 2. But what happens when I plug in 0? So plug in 0, plug in 1, see what happens. And then I'd also plug in -1 and -2, just to see what happens. When I plug in -1, what happens? When I plug in -2, what happens? And go from there. So here we go. If you plug in 0, that's 0, so you end up with -2 inside of there. Absolute value of -2 is 2, but then this negative makes it back to -2. I know that's a lot of talking, but here, I'll show it. It's almost easier to talk yourself through it than this negative, and then this is the absolute value. When you subtract this, you get absolute value of -2. The absolute value of -2 is 2. But we still have this negative sign out front, so that makes -2, so that makes 0. So not the easiest thing to plug in and evaluate, but if you keep everything straight, you'll be good. So it looks like it's there, 0, 0. When I plug in 1, now, I get that this does not look like it's 3 to 1, but if you think about the rise and the run of this rises 2 and it runs 2/3. Okay, so if you did the rise and run, the slope between those 2 points right there, you'd have a rise of 2 and a run of 2/3. And guess what? When you do 2 divided by 2/3, you get 3. So my slope is still preserved, and from this point I could just go down 3 and over 1 and expect that to happen. Now obviously I could plug in 1. When you plug in 1, you do get -3. Okay, so you can get these different ways. Now, what happens when I plug in -1? I will tell you that you do not get 0. Okay, you will actually get +1. Now, this is kind of hard to show, but if I wanted to find the slope between these 2 points, I could do rise and run. Well, from 1 to 2, that's a rise of 1. It rises 1, and it runs 1/3. Well, guess what? 1 divided by 1/3 is 3. Okay, so between those 2 points, I still have a slope of 3 to 1. It's equivalent. And then so I could go down 3 and over 1, down 3 and over 1, and still preserve that slope. Or obviously I could plug in -2 into the equation and get -2. Now the hard part to seeing this, when you evaluate at the end, it doesn't seem symmetrical because your points are kind of off. But if you draw a good line of symmetry, you'll see that this is still symmetrical. All right, you could add points here if you wanted, and you could see that they're equal distance away. Okay, domain is all reals. Range goes up to 2, so that's from -infinity to 2. Go from there. All right, this one I'll go a little bit faster. Again, to find this x-coordinate, I have to set that equal to 0, and subtract 3, divide by 2. So now, the x-coordinate is -3/2, which is just -1.5. And then k is 1. So -1.5, 1 is right there. So that's my starting point. I'm expecting this to look like that because there's a negative out front. So it just kind of helps because when you go to plug in use your XY chart and you use -1, 0, 1, you're expecting to get points that are down here. Now, when you plug in -1, you get 0. I'm not going to talk you all the way through that. You can figure that. When you plug in 0, you get -2. Plug in 1, you get -4. Now, you might be wondering how I knew that. I don't really have a cheat sheet on me right here. I just know that it rises 1 and it runs half right here. Well, 1 divided by 1/2 is 2. So I have a slope of 2 here, just like it says in the equation here. The slope is 2. So I go down 2 and over 1, down 2 and over 1, and I have that consistent slope. Same thing going the other way. If I plug in -2, -3, -4, I still know my slope is 2 to 1, or 1 to 1/2. It's the same ratio. So I could do that 2 to 1 ratio and continue that. And this one comes out, it looks more symmetrical because your points line up. But the previous one was symmetrical also. Domain, all reals. Range goes up to 1. Remember, this is a max point. So we go -infinity, that's a bad infinity sign, up to 1. And our slope, again, I can get that from out front. It's -2 and +2.